about free fall of an object and acceleration. Let's understand this with an example. When ball was dropped from the building, it falls towards the surface of the earth. Now just imagine here is the building and ball was dropped from the building and it falls towards the surface of the earth or it hits the ground. Now this is because of gravitational force. So this is because of the gravitational force which earth exerts on this ball. Now such objects which are under the action of gravitational force and no other object forces are acting on it. So no other forces are acting on it, then we can say that this object is under free fall. When it was falling from certain height to the ground, when I said there is no other forces acting on it, I mean forces like air resistance and frictional forces are not acting on that object. The only force which is acting is the gravitational force which is acting on an object. So such objects are said to be free fall. So in this case, this ball which is falling towards the earth surface, which is what we call is freely falling body. So the definition of free fall is an object is said to be in free fall when its motion is purely because of the action of gravity. No other forces are acting on it except gravity. So when an object falls down towards the earth under the gravitational force alone, we say the object is in free fall. So the falling of a body from a height towards the earth under the action of gravitational force of earth with no other forces acting on it, that is known as free fall. Acceleration due to gravity. When a body is dropped from a certain height, it falls with a constant acceleration. This uniform acceleration produced in a freely falling body due to gravitational pull of the earth is known as acceleration due to gravity. Whenever an object falls down towards the earth, an acceleration is involved. This acceleration is due to Earth's gravitational force. Therefore, this acceleration is known as acceleration due to gravity, and it is denoted by g. We already know two things, that is capital G and another is small g. We know that g is a proportionality constant and it is known as universal gravitational constant, and another is acceleration due to gravity, which is denoted by small g. Now we will find the value of g. Before that, we know that F equals to mass into acceleration. Here A is the acceleration. Now if we involve gravity, then it is A equals to g. Alright, what I said is, here A is the gravity. We replace acceleration with gravity, that is F equals to m into g. In the place of A, we should write g. So that's why we have taken F equals to m into g. We know that F equals to capital G m small m upon d square. Let's take this as equation 1 and this as equation 2. So I will equate these both, that is capital G m small m upon d square equals to m into g. Here we will cancel these both m's, these both masses are cancelled here. So we get g equals to capital G m upon d square. So here acceleration due to gravity is equals to capital G m upon d square. Also the unit of g is the same as that of acceleration, that is meter per second square. Although g varies very slightly from place to place, but its average value is taken to be 9.8 meter per second square. This means that the velocity of a body increases by 9.8 meter per second every second. Say if the body is dropped with zero velocity, its velocity becomes 9.8 meter per second. After 1 second, 19.6 meter per second. Then after 2 seconds, its velocity will be 27.4 meter per second. And after 3 seconds and so on. Similarly, if a body is projected upwards, its velocity decreases by 9.8 meter per second after every second. Why does the moon not fall to the ground? When an object falls down towards the earth under gravitational force alone, we say the object is in free fall. Then why moon doesn't fall to the earth? So before moving to this topic, first we will do an activity. So for doing this activity, take a piece of thread, tie a small stone at one end, hold the other end of the thread and spin it around. Rotate it rapidly. Then note the direction of the stone. Release the thread. Again note the direction of the motion of the stone before the thread is released. So you can observe here the stone moves in a circular path with a certain speed and changes the direction at every point. The change in direction involves change in velocity and acceleration. As you can observe here, as the stone is moving, the direction is also changing. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. This force is called centripetal force, meaning center seeking force. In this absence of this force, the stone flies off along a straight line. This straight line will be a tangent to the circular path. So here, a tangent means a straight line that meets the circle at one and only one point is called a tangent to the circle. Straight line ABC is a tangent to the circle at point B. So in this activity you can observe that as the stone is moving, the direction is also changing. The body is moving along the circular path and is acting toward the center. Now, why does the moon not fall to the ground? Or also we can call it as why does the moon not fall to the earth? The moon doesn't fall to the earth because of the balance between the gravitation force between the two bodies and the moon's velocity and distance from earth. Look here, this is the path of the moon. So here is the earth and here is the moon. Moon velocity direction is tangent. If t equals to 0, then t equals to 1 should be here along the direction of velocity. So this is the path of the moon. You can observe here. This is the path of the moon. Moon velocity direction is the tangent. If here the time is in 0 seconds, then here it should be t equals to 1. So if it is here, then it is in the center. Then if the tangent is here, moving in the center. So in every second towards the center, this object is moving. It is moving towards the center of earth. Moon is moving towards the earth because of gravitation force. If there is no gravitation force, then it won't be moving. So because of the balance between the gravitation force between the two bodies, that is moon's velocity and the distance from earth, the motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. So what I want to tell you is the moon moves in a circular orbit around the earth. If there were no centripetal force, the moon would have pursued a uniform straight line motion. The moon moves in a circular orbit around the earth due to the centripetal force provided by earth's gravitation field. So, like I said in the activity, the stone moves in a circular path. As the stone is moving, the direction is changing. There is a change in direction. So, the change in direction involves change in velocity or acceleration. Here, here also the moon moves in a circular path with a certain speed, and it keeps on changing the direction at every point. You can observe here, the moon keeps on changing the direction. It moves in a circular path. It is moving towards the center of the earth because of gravitation force. The moon's distance from earth allows it to maintain a balance between falling and escaping. The moon's velocity keeps it from falling into earth. So it is a velocity of moon that keeps it from falling into earth. If the moon's velocity were faster, it would escape earth gravity. And if it were slower, it would fall to the earth. So the mass of the moon equals to 7.34 into 10 to the power of 22 kg, and mass of earth is equals to 6 into 10 to the power of 24 kg. So the moon doesn't fall to the earth because of the balance between the gravitation force between the two bodies, that is the moon and the earth. If there were no gravitation force, then it won't be moving in a circular orbit. Also, in our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and the planets. Newton concluded not only Earth attracts the moon, but all objects in the universe attract each other. This force of attraction between objects is called gravitational force. So this video was all about free fall of an object, acceleration due to gravity, and why does the moon not fall to the ground. I hope this video was understandable to you, and I hope these concepts are clear to you. Also, don't forget to subscribe. If you like my video, share it with your friends.